Okay. So given a 90% confidence interval of 95 and 105 for mean heart rates, which of the following best interpret the confidence interval? We are 99 or 90% confident, right?
Yeah.
Okay. Using all this information, what do you guys get for number 3?
I said confidence interval when sigma is unknown. But I was a little confused.
Did you do number 3?
Hold on. Oh, I said that the distribution of the mean for each sample is normal since they can apply the central limit theorem.
So what was the central limit theorem? That was
It has to be larger than 30. Unless the distribution is normal.
well, because it doesn't give us a number, so we don't know the size.
The size is 20 females and 15 males.
No, is it? Okay. So it's not larger than 30, but it is normally distributed. So would it be yes, but because the sample is normal sized? Is that it, or would it be the central limit theorem?
I don't think it's the central limit. I just thought I remembered reading that somewhere. We can go with the mean of each sample is normal.
Okay.
Since the data is determined to be normal.
Okay. So now number 4. Which of the 4 type confidence interval listed below would be appropriate?
I was thinking since we're testing 2 groups and we're finding the difference between them, but then I wasn't sure between the dependent or independent. I was thinking more the independent samples.
Yeah, I think it would be independent just because if you choose a female, it doesn't necessarily mean you're choosing a certain male. So
Yeah.
okay. So now number 5. With all this, what would make it a smaller margin of error?
Is that just computing a 99% confidence interval? Or does that make it bigger? That makes it the margin of error bigger. If you increase the sample, though, it makes it smaller.
So obtain balance of 90.
Yeah, that's what I remember.
Yeah,
Anyways.
that's what I put. Okay. So now with this information, determine the margin of error. Did you guys get an answer?
I actually got an first cover. I don't know for sure if she did or not. Okay. Sorry. This isn't you. You didn't just put this in an Excel, right? Because
No, because you
you just
just
calculate it with the z times sigma over sample size.
yeah. Did you get 190 or 1.96?
Yeah.
Yeah.
Okay, number 7. What is the lower bound? So if you just subtract that from 1,000, you should get 998.04.
Yep. But you have to add another 0 for it
Well,
to make.
Yeah. And then the upper bound is 1001.960.
Yep.
Yeah. So now within this information, how large should the sample size be? And you can say if you have an answer.
Okay, this is the one that you plug into the formula, right?
Yeah, you put in the formula, but then solve for
And
instead of margin of error.
And I could only find the formula for the unknown, or for the. Do we know?
Well, the formula should be like for margin of error that the stat score, then times the standard deviation divided by,
Square root of n.
yeah.
I got 38,416.
Would you round? Or did you round already?
I already rounded. I didn't get any decimals.
Didn't?
Not that I remember. I can do it again.
So I think when I did it was that, but 0.6 something.
Yeah, I didn't get any decimals.
So are you doing the 1 plus or minus 1.96 times 0.01 over the square root of n? Or is that not even close to what you
The
could do?
equation you use to find n is n equals z, the z score, times standard deviation divided by margin of error, and then you square root that all.
Would you square root it or would you square it?
Square, sorry.
Yeah, because you would have.
So we got 38,416. 38,416.
Okay. I'll just guess mine rounded somewhere where it wasn't. Okay. So 6. Okay. Save. Okay, so with this information, what should the null and alternative be?
Shouldn't it be less than?
Yeah. Okay, and when do we reject the null?
It's when the p-value is larger than the significance,
Isn't it?
right?
I thought it was less than.
It's less than.
You fail to reject or just reject?
No, you just reject.
Reject. Okay. Mm-hmm.
Okay, now with this information, are we able to do an ANOVA test?
I had no idea on this one because I don't remember ever really talking about a bell shape, and I thought it was skewed right.
Yeah, I was at first confused on this one, but then I looked at like the requirements for it, and then so the requirements are it must be normally distributed, but then eventually it like comes out to being right skewed. If
I
that
was
makes sense.
thinking yes, because there's there's 4 different apartment buildings. And that's the only test that tests multiple groups.
So yes, the data for each apartment are bell shaped with no outliers, and the variances are nearly equal.
That's what I put.
Yeah.
Just because that's what it says in the book of the requirements. It must be normally distributed, and then the variance has to be nearly equal. Okay, so with this information, if you reject the null even though it was true, what type error
So
was that?
type 1, right?
Yeah. Okay, so now if level significance A is made very small, making the probability of turning it a type 1 error small, what happens to the probability of a type 2? Aren't those irreversible? Like, I guess, what is this? The word?
Inversely related.
Yeah. Inversely.
So by reducing the probability of committing type 1, you increase the probability of committing type 2.
Yeah.
Increase. Wait, so if we reduce type 1 error, we also reduce type 2 error, or?
No, we increase type 2 when we.
Yeah, that's what I was thinking. I was like, what? Okay.
Okay, so now with this information, what do we conclude? So you find the p-value. No. No. So I chose fail to reject, but that's what I thought. I think you should get a z-score of 0.176 if I did it correctly. Oh man, this is a long test.
Yeah. It's longer than the other one. It didn't have that many questions.
Yeah, this one was super long. This is almost long as like one of our actual tests.
Yeah.
Okay, I got failed to reject.
Failed to reject.
Okay. So now moving on. Now, which type test would we use? Or no? Yeah. What statistic? No. Yeah. What type? What do you guys think for number 10 or 16?
I said pair, but I can't remember why.
I think it's just independent. Just because
Yeah, I think
it's
that would
not.
be
Yeah,
independent.
yeah, I think I'm thinking of a different one.
The
Yeah.
brother sister one. The next one's dependent.
Okay. So now number 17. What you guys put?
Dependent, because if you select the brother, you compare his academic achievement to his sister, you must select the sister.
Okay. So now
This is the one.
what type of test are we doing for this next one? This is
What one?
18. I was just
17? 18?
yeah. Mm, This is how far I got on doing it beforehand.
I skipped this one because I didn't know.
Guess what's the data look like? So do we just do a one sample t-test? Is that what we're doing?
Yeah, I think that'd work.
Mm-hmm.
I don't remember why I couldn't get this one to work.
Like, does it give us anything about sigma being known?
No, not really.
So yeah, so we just do a confidence interval for mu when standard deviation is unknown. Number 18.
Yeah.
Okay, so now if you plug that into program, you should get for the margin of error nothing.
Nothing.
Oh, because it doesn't. Oh wait, is the standard error of the mean the same thing as margin of error?
That's what I'm wondering, because I get 0.967.
Yeah, let me double check if that's correct. 13.193. I'm not sure if that is correct or not. That's because.
Hold on. That's just.
Okay.
The standard deviation. Let's see, where are we?
Right.
So 4.35, 425, 2 over the square root of 20.
Would it be 2.014?
About 1.895. What did you use?
So I just looked at the confidence interval and the mean, and then subtracted one of the high value minus the mean. Because for the confidence interval, you get the high value is 15.217, and then the mean is 13.1. 193, or 193.
That makes sense. But I get 2.025, right?
2.014. And lower bound would be 11.168.
Hey, what did you get for the margin of error again?
0.025. You got something a little different.
Let me see.
Okay.
So I guess it depends on if you don't use the non-rounded, then okay. How did I get that one again? So what did you use for the mean? Did you use 13.1925 or 13.193?
I use 13.1925 or 285.
285.
That's just what my thing says, so I just have all the numbers.
Okay, yeah, so I think that with this one it's going to be just a estimate, just because remember when she says the SPSF is a little different or a little higher.
Yeah, I think it'll be okay.
So what are we deciding on?
You can decide on 2.20 or 2.014 or 5. So
Okay.
and okay, input the lower bound, or lower bound is 11.168. And
Yeah.
15.217.
Yes.
Okay, so now using a different information, use hammers. Because now with this test, what are we doing? Where's my? Yeah, there it is. Yeah. So what is it? So you want to know there's a difference in mean listings between Hummers in Los Angeles and Hummers in New York. That should be independent, right?
Mm-hmm. Because they're not.
Yeah. Differences, but it's independent.
Okay. So save that. And then, okay, so now with 95, 2 sample T. Let me get my. So which group is group 1, did they say?
From how they say it in the problem, they always put LA first.
Okay. Like it doesn't say like group 1 next to it?
No.
Okay, where's the price for the...
So would it be price in city, price in the test variable, and city in the grouping variable?
Wait,
Yeah.
Oh, dang it. I messed up. I decided to enter all of them and not separate it. So Los Angeles is first.
How do you go over there? Holy smokes. Did you get yours to work, Monica?
No.
Okay,
It does not work for finding differences for independent variables.
Yeah, I've never ever been able to get an independent variable to work.
yeah, so I'll quickly put this in so we can get an answer. Okay.
I still need to figure that out, but I literally have no idea how to.
Yeah, I don't.
Okay. Margin of error was 95, and are we doing equal to or non-equal to?
I thought we were only putting in the lower bounds.
Wait, what?
Lower bound and upper bound. We're just calculating the lower and
I know,
upper
but I was
bounds.
just, I don't, when I put it in, I think it might have changed the lower bound. Oh, no, it doesn't. That's p-value. Okay, so lower bound, I got a negative number, so negative 423.238. 423.238. And then the upper bound is 5,417.336.
6.
Yeah, so 5,417.336.
Okay.
Okay, so now we're using exercise bone density. Where is it? So what type of test is this?
I said the Nava, whatever you say it.
No,
Okay, there's multiple. Okay, so which, I guess it doesn't really matter which group is what. These ones.
No.
I don't think so.
Have you guys done this?
I
Like,
tried to put it in, but I didn't get it to work, so I'm gonna try it again.
yeah, I'm just gonna. Okay, now last one. Okay. So what are we trying to figure out now?
The test.
Test statistic?
Yeah.
So that was F with this one, right? So the test statistic is
Yeah, I think so.
okay, so for F I got 7.978.
That's what I got.
7.9. Yeah. Now p-value.
That's what I got. Sorry, 0.002.
0.002. Yep.
So 7.978, was that what we all got?
Yeah. Okay. Now, which of the following best expresses the conclusion of this test? So our p-value is less than. So we reject. So we have sufficient evidence to say something. What was the hypothesis?
That the bone density changes or something. Hold on a second.
Okay, so what's it?
It says
Oh, so determine. Researchers would like to determine if it is different.
between the three groups of rats. So it
So
fail, or we do reject the null.
yeah, we would reject it.
So
Well, with
there's
these ones, the null means like they're saying they're equal, and then the alternative is when they're saying at least one is different.
Yeah.
yeah.
So is it we have sufficient evidence at least one of the groups is different?
Yes, because we rejected. Okay, now direct fight costs.
No. I said dependent.
Let me double check. So what's it saying? So
Because you have to do the same flight for the 90 days and the 14 days.
yeah, so it'd be dependent. Now I just have to put this in. Which one goes first?
I don't know.
So would this be a paired samples t-test?
Yeah.
Yeah.
Oh gosh.
Okay, perform.
I have no idea if this is
I like we do 14 first.
I did 14 first. So I got the T is 1.685.
Yeah, that's what I got.
Okay, so what you got? 1.65?
1.685.
Mm-hmm.
Okay. Now, what's the p-value?
0.096. Oh,
Yep.
why
0.0.
is this not working?
Wait, so 0.06?
96. 0.096.
Okay, so then that is less than our. So we have sufficient evidence that there's a difference.
We have sufficient. No, we have insufficient. That there's a difference.
Wait, shouldn't it be sufficient because you do reject?
Yes.
But then which one is it that there is a
That there
difference?
is a difference.
Yeah.
We're wanting to know that there is a difference, right?
I think so, yeah. Because I think with this you reject the null, but then you state the alternative.
Yeah, I think so. I can't.
Okay, we'll just see what we got.
Let's be honest, I'm not going to do it over again.
Yeah.
I'm so tired.
Submit.
I missed 2.
Yeah, so did I. Which ones did we miss?
What were they?
Okay, so we missed the margin of error one on 19.
Okay.
Oh. Okay.
And Number 15.
15. Why is that? Huh. Oh well.
Yeah, we still got
Listen
an
to-
A.
Yeah, 93%. Okay, well, sweet.
Good luck on the test, guys.
Yeah, you guys
too.
too.
Guess we'll see you guys next. Wait,
Next
did you,
one.
Monica? Did you want to try the Excel? You want me to show you how to use Excel, just in case, or
No, I'll figure it out.
okay?
There's not gonna be that many problems on it.
Okay,
Okay. Thanks, though.
no problem. See you guys next week then.